Welcome. In this video, I would like to go over certain aspects of the 3D environment that we can now go over because we can extrude now, and also another way to make solids. You can see that I have my friend the tape holder here, and I have that ledge that we talked about in the last video. If I want to get a closer look at this ledge, it's helpful to know how to do that. Well, I have certain view controls up here that will come in handy now that we've got solids. The first one is zoom to fit. If I've got a solid way out here, I can click this zoom to fit button, and no matter where or in what orientation the solid is, it zooms to be the perfect frame. I can also do a zoom to location. So I click this button, draw a little square, and it zooms to that little square that I choose. Pretty simple. And I've got this button, which just takes me back to the previous view. Again, very handy. I have this button, which is probably my most used on this menu. It's the section view. Now notice we have 3 planes that we start off with, the front, top, and right plane. And I can section it out parallel to any of those planes or any other plane that I artificially create. I can take this plane and drag it parallel to the front plane at any point, and it cuts the section, or it cuts a section out of the solid so that I can view that ledge, for instance, a lot more clearly. And it can make views that are hard to get otherwise. So when I click the section view, I can be parallel to the top plane and move that up and down, and at an angle if I so desire. Or it can be parallel to the right plane. So I can get just about any section view that I want to. I can also choose a face, so I can choose this face and it snaps to that face. I can choose this face or this face. Any flat face I can snap to make a section view out of, which can also be very handy. This menu handles views. So this is clearly the top view. This view is the front view, the left view. So you can get normal to any side of this part. Okay. So these views, or the orientation menu, can bring the top, front, left, right, back, bottom. So you can click any of these and it will take you to that view to help you orient the part. Also, you can go with an isometric view, which is also very handy. You don't have to use this menu, however. You can push Control 1, 2, 3, 4, 5, 6, 7, and 8 to access all of these views. Now remember, Control 8 is normal to something, so if I choose this face and push Control 8, I become normal to that face. This face, Control 8, I become normal to it. This face, Control 8, become normal to it. So Control 8 is normal to anything, and the rest of the controls are for specific preset views. And that's why it's so important to orient the views like we talked about in some of the first videos according to the front, top, and right planes, so that the part will orient correctly the way you intend. This menu enables me to change the appearance of the part, so I can get rid of some of the hard lines, and notice no tangent line here anymore. Tangent line here, and it's gone. So this view can make it for a little bit more of a realistic rendering. It's called hard lines removed. Now I can do this hidden lines removed, and this is a view that enables me to look at the part without any shading whatsoever. I can go down to showing the hidden lines, and this shows me the interior surfaces of this feature, or this extruded cut that we made. And finally I can do a wireframe view, which doesn't even differentiate the internal and external features. So these are the view options that are available to me. You can hide and show certain things. So in this case I can hide or show my different planes if I want to see my front, right, and top plane if there's any question as to how I've oriented the part relative to the planes. You can show certain things like coordinate systems or points. Really it's easiest to keep these off by default most of the time. You can also edit the appearance of the part. You can do the same thing off of a right-click menu, which I prefer to do. And I can say Appearances. And do I want to put appearance on just that face, on the Boss extrude that made that face, on the entire body, or the entire part? So I'll choose the entire part, and I'll go with Appearances up here at this top menu. I can choose metal, and there are all sorts of different materials I can use. In the submenu I'll choose steel, and I'll choose a nice brushed steel. Now I have a pretty basic graphics on this setup, but if you are running a more advanced graphics, you'll be able to see the actual texture of what a brushed steel would look like. You can see all the individual channels that a brushed steel would look like. If you're curious, you can also look it up online if your SolidWorks looks like mine. You can also edit the background. Of course, we're looking at 3-point faded. One of the fun ones is you can do a courtyard, or you can do an urban background, almost looks like Detroit or something. Many of the backgrounds are kind of abstract with some colors, and many of them, especially as you go down the line, are just a photograph that you can move the part in front of. So you can, I don't know, model Santa's sleigh and put it in this picture so it looks like Christmas or something. So you have some options on the background, and this handles perspective. You can see that it looks a little bit more realistic, that the front is larger than the back with perspective turned on. You can do or undo shadows. You can see how the shadow goes away when I do that. Ambient occlusion, which is a little bit more realistic when you have really high graphics running, and cartoon, which is just another way of viewing things. So I'll go back to 3-point faded. Well, if I wanted to model something like this, let's call it a donut or a bagel in SolidWorks, or an O-ring or something of this shape, how would I extrude this? The answer is with a huge amount of difficulty. So instead of extruding, I want to show another way of being able to create solids that are specifically for rounded objects. To do that, I will open a part, and I start off by choosing a plane, Control 8, making sure I'm normal to it, and I'll draw a center line first thing. This is a technique known as revolving in SolidWorks, and it's very useful. You don't have to, but I will dimension my instruction line. I'll make a circle. This will be the circle that makes the donut, and I'll give the circle a diameter of 2 inches. I'll give this, say, 1.75, and then for good measure I'll select a midpoint, select the center of the circle, and make them horizontal. So we're fully constrained. Again, very important to fully constrain. Now I can go to the Features menu because I'm ready to generate a solid, and one of the options here next to Extruded Boss Base is Revolved Boss Base. When I choose that, it automatically detects my center line and my circle, and what it's saying is I'm going to use this as a center line, and I'm going to move this circle 360 degrees around this line and add material as I go all the way around. So when I click the checkbox, I've made, in this case, a donut. Now the Revolve has a lot of options associated with it. So when I edit the feature, I can choose 180 degrees if I want to. And I've made, I don't know, something that looks like an arch. So I can specify the amount of rotation I want within the Revolve menu. I can also revolve up to a surface or a vertex, which in this it works the same way as extrude. In this case it's not very applicable, but maybe I should do a example in case anyone is curious or doesn't understand. So I'll open up our friend the tape again. Alright, so if I want to create a sketch on this face, now obviously no tape holder would ever have this feature, so this is just for example only, because this is in no way realistic by any means. In fact, I'd venture to say that what we're making now is a pure example and no longer a tape holder. So if I give this 1/2 inch and I create a center line, say right along this tangent point. I guess that's not really a tangent point because you're not tangent right there. This would be an edge and this would be a tangent point. But at any rate, if I do a Revolve Boss base, it recognizes my line and it recognizes what I want to revolve to. This is going all the way through the part. Of course, let's say I want to not only revolve it a certain number of degrees, like 185, and I can switch my side here, but I want it to be perfectly flat and not have this little edge right here. Instead of doing a blind, I can do an up to surface, which takes away my option for degrees because it automatically does degrees at the surface. And notice it stops at the surface and it curves with the surface, so it's not flat like a blind revolve would be. I can do up to vertex, so I can choose up to the height of this point, or I can respecify. It failed to revolve because of the angle of that certain vertex. I can do it up to that point there. So lots of options with the vertex. I can revolve offset from a surface, so it can match the surface but be 0.1, 0.2, 0.3 inches above that surface. So that's how the offset works. In fact, that's kind of a trippy looking feature if I accept that. Of course, no tape holder would ever look like this, but it makes for a decent example of how revolves work, rather. So as a quick example, what if I wanted to model something like this? I would definitely want to use the revolve. It would be the easiest way to do it. And if I take a section view, it gives me a nice cross section of what it looks like. So all I really have to do is sketch something like this and make a revolve line, and as this profile goes all the way around, I can add material and make it look like this. So if I make a new part, and I'll choose my front plane, Control 8, sketch, sketch, make a center line that's vertical. I don't actually need to constrain this. I often do for good practice. And then I can make that same profile that I saw. I can make that vertical. Choose this line, the outside. We'll make that 12 inches. We'll make this, I didn't mean to add an angle there. We'll make this 1/4 inch. Make this 1/4 inch. This 1/4 inch. this 1/4 inch, 1/2 inch tall. It looks like I could put a 1/2 inch over here, or of course add in a relation of collinearity. Now, features, revolve. It recognizes my center line and my feature. If it doesn't recognize the center line, if it tries to do something silly like revolve it around this, you can always go up to axis of revolution and choose that. You can also say selected contours, and you can choose any features that you want to revolve if it doesn't default correctly. You can choose the thin feature, which is a pretty common feature. The thin feature allows you to do a certain thickness around your sketch. So if I go 2/1000ths of an inch thick, you can always specify the other direction. And make it 2/1000ths in the other direction. And when I section it out, you can see that it made it a hollow thin feature 2/1000ths of an inch thick. So you can do the thin feature if you want to make some hollow features. Thin features also work on a non-closed sketch. So if I edit my sketch, try to rebuild it, the thin feature makes it so that I don't actually have to have a closed sketch like we talked about earlier. So the thin feature can be very handy in making revolves in that way. So that is an overview on how to revolve. Go practice this, make as many revolves as you can, get familiar with it, and I'll see you in the next video.